In the darkest days of World War II, Nazi Germany pursued weapons of unimaginable destruction. While the V-2 rocket and atomic bomb projects are well known, there existed a plan so audacious, so seemingly impossible that it sounds like science fiction. The concept originated with Hermann Oberth, one of the founding fathers of rocketry and spaceflight. Born in 1894 in Transylvania, Oberth's pioneering work on rocket propulsion laid the groundwork for both space exploration and warfare. But in 1929, he published an idea that would capture the imagination of Nazi weapons designers. A giant mirror in space that could focus the sun's rays like a magnifying glass, turning houses or whole cities into funeral pyres. The concept of weaponizing reflected sunlight wasn't new. Ancient Greek mathematician Archimedes allegedly used bronze mirrors to set Roman ships ablaze during the siege of Syracuse in 212 BC. Whether this actually happened remains debated by historians, but the legend persisted through centuries. The basic principle is simple. Mirrors can concentrate solar radiation into a focused beam of intense heat. What Oberth proposed was taking this ancient concept and scaling it up to cosmic proportions. In his 1929 book, Wege zur Raumschifffahrt, Ways to Spaceflight, Oberth included a chapter describing a space station equipped with a massive concave mirror. This mirror, he calculated, could be 100 meters in diameter or larger. Positioned in orbit, it would continuously face the sun, collecting and concentrating solar energy. By adjusting the mirror's angle, operators could direct this concentrated beam to any point on Earth's surface below. The temperature at the focal point could theoretically reach thousands of degrees hot enough to vaporize steel, boil oceans, and reduce cities to ash. Oberth envisioned this not primarily as a weapon, but as a tool for weather modification and even melting ice caps to create new shipping routes. But the military implications were obvious and terrifying. When Adolf Hitler and the Nazi Party came to power in 1933, Germany began a massive rearmament program. The Versailles Treaty had severely restricted German military capabilities, so Nazi strategists sought revolutionary new weapons that could overcome their enemies' numerical advantages. They pursued jet aircraft, ballistic missiles, and eventually nuclear weapons. In this climate of weapons innovation, Oberth's space mirror concept found receptive ears. By the early 1940s, German scientists at various research institutions began seriously studying the sun gun concept. The project was investigated at the German Army Artillery, Proving Grounds, and gained support from some high-ranking military officials who saw its potential as the ultimate terror weapon. Unlike bombers that could be shot down or missiles that could be intercepted, a weapon in space would be completely invulnerable to enemy attack. It could strike anywhere on Earth with no warning, no defense possible. The project's feasibility depended entirely on German rocket technology. Fortunately for the sun gun planners, Germany led the world in this field. Under Wernher von Braun, the team at Peenemünde had developed the V-2, the world's first long-range ballistic missile. First launched successfully in 1942, the V-2 could reach the edge of space and strike targets 200 miles away. If rockets could reach space, then perhaps space stations and orbital mirrors weren't so far-fetched after all. The sun gun, as designed by German engineers during the war, would be part of a larger orbital complex. The space station would orbit at an altitude of approximately 5,100 miles, well above what we now call low Earth orbit. At this height, the station would complete one orbit every 24 hours, allowing it to remain positioned over a specific region of Earth. The station would house a crew of scientists and soldiers who would maintain the weapon system and select targets. The mirror itself represented the greatest engineering challenge. German plans called for a reflector between 3 and 9 square kilometers in area roughly the size of a small town. One concept used sodium metal, which is highly reflective, formed into thousands of small mirror segments that would be assembled in orbit like a cosmic jigsaw puzzle. These segments would be held in a parabolic shape by a framework of steel cables and supports. The entire assembly would slowly rotate to track the sun, while a sophisticated pointing system directed the reflected beam toward Earth. The physics was straightforward but staggering in scale. The sun delivers approximately 1,400 watts of energy per square meter at Earth's distance. A mirror 6 square kilometers in area would collect over 8 billion watts, 8 gigawatts of solar power. By concentrating this energy into a focal point just a few hundred meters wide, the beam would deliver temperatures exceeding 3,000 degrees Celsius. For comparison, steel melts at 1,400 degrees. Wood ignites at around 300 degrees. A city struck by the sun gun would simply cease to exist. German documents outlined a development timeline spanning 10 to 15 years. The first phase would involve launching components into orbit using advanced rockets, descendants of the V-2, but far more powerful. Teams of astronauts would assemble the mirror segments in space, a task requiring dozens of spaceflights. Once operational, the sun gun could target any point on Earth's surface that fell within its field of view. The beam could be sustained for minutes or hours, ensuring complete destruction of the target. Rivers could be boiled away, forests incinerated, and entire armies annihilated in seconds. The sun gun couldn't exist in isolation. It required a permanent human presence in space to operate and maintain it. German engineers designed an ambitious space station to house the weapon's crew. The most detailed plans called for a wheel-shaped station, rotating to generate artificial gravity. This design, ironically, would later inspire peaceful space station concepts in the 1950s and 60s. The station would house between 20 and 50 personnel, including engineers, scientists, soldiers, and a command staff. Living quarters would be cramped but functional, with space for sleeping, eating, and recreation. The crew would work in shifts maintaining the mirror array, making targeting calculations, and operating the weapon system. German planners even considered how to supply the station with food, water, and air problems that wouldn't be practically solved until decades later. Supply missions would launch from Earth every few weeks, carrying provisions, replacement parts, and crew rotations. Each launch would be enormously expensive and technically challenging. The Germans estimated that operating the sun gun would require a permanent fleet of heavy-lift rockets, massive ground infrastructure, and thousands of support personnel. The cost would be astronomical, perhaps consuming a significant percentage of Germany's entire military budget. From their orbital perch, the station crew would have a godlike view of Earth. Through powerful telescopes, they could observe weather patterns, track ship movements, and identify military targets. Once ordered to fire, the crew would orient the station, adjust the mirror array, and unleash the sun's fury. The beam would be invisible from space, but observers on the ground would see their doom approaching as the focused sunlight created a blinding spot of light, growing larger and hotter with each passing second. The sun gun's feasibility rested entirely on the shoulders of one man, Werner von Braun. Born in 1912, von Braun had been obsessed with spaceflight since childhood. By age 25, he was technical director of Germany's rocket program. His genius and ambition drove the development of the V-2, but his ultimate dream was space exploration, not weapons of war. The V-2 represented a quantum leap in rocket technology. Standing 46 feet tall and weighing 27,000 pounds at launch, it could carry a 1-ton warhead over 200 miles at speeds exceeding 3,500 miles per hour. More importantly, it reached altitudes of 60 miles, the threshold of space. Between 1944 and 1945, Germany launched over 3,000 V-2s against Allied cities, particularly London and Antwerp. The rocket was inaccurate and expensive, killing more slave laborers during construction than enemy civilians, but it proved that space was within reach. At the Peenemünde research facility on Germany's Baltic coast, von Braun's team was already working on the V-2's successors. The A9-A10 America rocket was designed to strike the United States from launch sites in Europe, a journey of over 3,000 miles. This two-stage rocket would have been powerful enough to place small satellites in orbit. Had the war continued, Germany might have achieved the world's first satellite launch by 1946 or 1947. Von Braun was aware of the sun gun concept and had been consulted about its technical feasibility. While he expressed skepticism about the weapon's practicality, he didn't dismiss it as impossible. The rocket technology was progressing rapidly enough that orbital stations might be achievable within 15 to 20 years. Von Braun's personal interest lay in using rockets for scientific exploration and human spaceflight, but he was willing to work within the Nazi military system to advance rocket science, a moral compromise that would haunt him for the rest of his life. To understand how the sun gun would work, we need to examine the physics of concentrated solar energy. Anyone who's used a magnifying glass to focus sunlight has seen this principle in action. The lens gathers light from a large area and concentrates it into a small focal point. The temperature at this point increases dramatically because the same amount of energy is compressed into a much smaller space. Modern solar thermal power plants use this exact principle. Thousands of mirrors called heliostats track the sun and reflect its light toward a central tower where the concentrated heat boils water to drive turbines. These facilities can achieve temperatures over 1,000 degrees Celsius at the focal point. The sun gun would work similarly, but on a vastly larger scale, and with the target being cities rather than power generation equipment. The key engineering challenge was achieving the correct focal length. A parabolic mirror focuses parallel light rays to a single point at a specific distance determined by the mirror's curvature. For the sun gun, the focal point needed to be about 5,000 miles away on Earth's surface. This required an extremely shallow parabolic curve across a massive diameter. Even tiny imperfections in the mirror's shape would scatter the beam, reducing its intensity and rendering the weapon useless. Another major obstacle was Earth's atmosphere. Anyone who's noticed how the sun appears dimmer through clouds or haze understands atmospheric absorption. The sun gun's beam would have to penetrate 5,000 miles of space and then Earth's entire atmosphere. Air molecules would scatter and absorb some of the beam's energy, reducing its effectiveness. Clouds could provide partial shielding, though the beam's intensity would likely boil away cloud cover within seconds. German calculations suggested that even with atmospheric losses, the weapon would retain enough power to be devastating. Despite the sun gun's theoretical promise, practical development during World War II was virtually impossible. By 1943, when serious attention was given to the project, Germany was already losing the war. Allied bombing campaigns were devastating German cities and industrial capacity. Resources were desperately needed for conventional weapons and basic defense, not speculative superweapons decades away from completion. The Sun gun would have required an enormous industrial effort. Engineers estimated needing tens of thousands of tons of refined metals, particularly aluminum and sodium, formed into precision mirror segments. Manufacturing would require specialized facilities immune to bombing, perhaps underground factories like those used for the V-2. Germany simply didn't have the resources, time, or security to undertake such a project while fighting a losing war on multiple fronts. Moreover, Hitler and his inner circle increasingly favored weapons that could deliver results immediately. The Führer was interested in the V-2 because it could strike London within months. He pursued jet fighters and wonder weapons that promised to turn the tide of battle in weeks or months, not decades. A space mirror that wouldn't be operational until 1960 held no appeal for a regime that wouldn't survive past 1945. There's also the horrific human cost to consider. V-2 production relied heavily on slave labor from concentration camps, working under brutal conditions that killed thousands. Any attempt to build the Sun gun would have required similar exploitation of forced labor on an even larger scale. The project wasn't merely technically impractical, it represented the Nazi regime's utter disregard for human life, both in the weapon's intended use and its construction. As Allied forces advanced into Germany in 1945, intelligence teams raced to capture Nazi scientists, documents, and technology. The Alsos mission and Operation Paperclip sought to secure Germany's scientific secrets before the Soviets could reach them. Among the thousands of pages of documents recovered were references to the Sun gun project. In July 1945, the United States War Department released a report titled Nazi Plans for Solar Energy Weapon. The document described German proposals for space-based mirrors capable of destroying cities. American intelligence analysts assessed the concept as theoretically possible but far beyond Germany's or anyone else's capabilities. The report generated brief media attention, with Life magazine publishing an article about Nazi superweapon plans, but it was quickly dismissed as science fiction. When von Braun and his team surrendered to American forces in May 1945, they brought with them years of rocket research data. Interrogations revealed that while von Braun was aware of the Sun gun concept, he had never seriously worked on it. His focus had been on ballistic missiles and, secretly, his dreams of space exploration. The Americans were far more interested in his V-2 technology than speculative space weapons. Within months, von Braun and hundreds of German rocket scientists were relocated to the United States to continue their work, now for their former enemies. After the war, scientists in America and other nations conducted theoretical analyses of the Sun gun concept. The consensus was clear. While not physically impossible, the weapon would be extraordinarily difficult to build and ultimately impractical. The engineering challenges were immense. Creating and maintaining a multi-kilometer mirror array in space would require solving problems in material science, orbital mechanics, precision assembly, and life support that wouldn't be addressed for decades. Let's examine why the Sun gun remained firmly in the realm of fantasy. First, the sheer cost would be prohibitive. Modern estimates suggest that building such a weapon system would cost hundreds of billions of dollars in today's currency, more than most nations spend on their entire military in a decade. Even for Nazi Germany at the height of its power, this expense would have been crushing. Second, assembly in space presented unsolved problems. The mirror segments would need to be positioned with millimeter precision across several square kilometers, maintained against micrometeorite impacts and thermal expansion. and kept properly oriented despite orbital perturbations. Third, targeting accuracy would be nearly impossible. The beam would need to be aimed with extraordinary precision to hit a specific target from 5,000 miles away. Earth's rotation, atmospheric refraction, and the station's orbital motion would all need to be calculated continuously. The computational requirements would exceed what was possible with 1940s technology by many orders of magnitude. Fourth, and perhaps most critically, the weapon would be vulnerable despite its orbital perch. Once an enemy knew the space station existed, they could launch missiles or eventually their own space vehicles to destroy it. The time and resources needed to rebuild would be enormous. As a practical weapon system, the Sun Gun offered questionable advantages over conventional strategic bombers or later intercontinental ballistic missiles. Beyond technical impracticality, the Sun Gun represents something darker: the Nazi regime's willingness to pursue weapons of unlimited destructiveness. This wasn't a weapon for military targets, it was designed to incinerate entire cities, killing hundreds of thousands of civilians in minutes. The concept aligned perfectly with Nazi ideology of total war and racial annihilation. Had it been built and used, the Sun Gun would have been a weapon of genocide, capable of destroying entire populations with no warning and no defense. The fact that Nazi Germany seriously studied such a weapon reveals the regime's fundamental evil. They weren't interested in winning battles or even winning wars in traditional senses. They sought absolute dominance through terror and mass murder. This moral dimension makes the Sun Gun particularly chilling. Even today, when we possess nuclear weapons capable of similar destruction, there's something uniquely horrifying about a weapon that uses the sun itself as an instrument of death. The sun gives life to all things on Earth. The Nazis wanted to turn it into an engine of extinction. Despite never being built, the Sun Gun left a lasting legacy. The concept influenced post-war science fiction, appearing in novels, films, and comic books. It became a symbol of Nazi Germany's twisted scientific ambitions and the dangers of weaponizing space. The idea that orbital platforms could threaten Earth below became a staple of science fiction and later strategic military thinking during the Cold War. More positively, the technical studies conducted for the Sun Gun contributed to genuine space science. The engineering challenges identified orbital assembly, large structures in space, precision pointing systems were real problems that later space programs had to solve. Von Braun's work on the V2, partly motivated by dreams of space stations like the one needed for the Sun Gun, directly led to the Saturn V rocket that took humans to the moon. The concept also prompted early thinking about space law and the weaponization of space. Would orbital weapons be legal? Who would control space? These questions, first raised by projects like the Sun Gun, eventually led to the Outer Space Treaty of 1967, which banned nuclear weapons and weapons of mass destruction from space. The Nazi Sun Gun remains one of history's most audacious and terrifying weapons concepts. It represented the ultimate expression of total war, an invulnerable weapon in space capable of destroying cities at will, powered by the very source of life itself. That it was never built owes nothing to Nazi restraint and everything to the concept's technical impossibility and Germany's defeat. Today we possess the technology that Nazi Germany lacked. We can build space stations, assemble large structures in orbit, and maintain permanent human presence beyond Earth. Modern solar power satellites collect energy from the sun and beam it to Earth, though using microwaves rather than focused light. We could, theoretically, build something like the Sun Gun if we chose to. That we haven't speaks to humanity's better nature and the international agreements that keep space peaceful. the sun gun story serves as a warning. Scientific capability must be guided by moral wisdom. The fact that something can be built doesn't mean it should be. As we continue expanding into space, we carry with us the responsibility to ensure that the cosmos remains a realm of exploration and discovery, not a new battlefield for weapons of mass destruction. The Nazi sun gun existed only on paper, in the fevered imaginations of weapons designers who served history's most evil regime. Let it remain there a cautionary tale of what happens when brilliant minds serve malevolent purposes, and a reminder that humanity's reach for the stars should be guided by hope, not hatred.